thank you for attending this T3 seminar on pressure. The goal of this T3 session is to give you a better understanding of the Yokogawa pressure offering so that you will see that Yokogawa pressure is best for your application. Before we dive in, I also want to introduce some of you and refresh the other attendees to TechStar. We are a manufacturer's representative for instrumentation, analytical, and machinery health applications. We have a full service and training department, excuse me, ready to assist you, as well as an in-house telemetry group. One of the manufacturers we represent is Yokogawa. Joining us today from Yokogawa is Matthew Snyder. He is our technical pressure specialist and sales specialist for our area, and he will be going over this presentation. So please type your questions if you have any, and we will go over them at the end of the presentation. And you also right now, if you'll look at the slide being shown right now, you can also see some of the other companies that we represent at TechStar. So Matt, please introduce yourself and go for it.
All right, thank you, Jason. All right, good morning, everyone. Like Jason said, I'm Matthew Schneider. I'm the field application sales specialist for the Southwest Territory. That includes Texas, Oklahoma, New Mexico, Arkansas, pretty much the territory that TechStar covers. I've been with Yokogawa for 9 years now. And like Jason said, my focus is on kind of growing the business, business development, and of course, supporting TechStar and their customers. Yeah, I just want to say again, appreciate everyone for joining this webinar. I know this is probably everyone's 100th or 200th webinar they've had to attend to during this kind of lockdown period. So we appreciate you guys choosing this one to attend. So yeah, today's topic, pressure, and more importantly, Yokogawa's offerings. Some of you guys here are longtime users of Yokogawa, but some of you guys may have not heard of Yokogawa or are looking at other options as far as pressure manufacturers. And so hopefully today we can kind of show you some of those differentiators and what Yokogawa actually manufactures. So for you guys who are not familiar, Yokogawa has been around for a long time. We won't dive too deep into this, but 105 years. We're pretty much every continent you can find Yokogawa. As far as a global aspect or global view, Yokogawa is probably one of the most trusted automation companies. We don't just make pressure transmitters, okay? We have a full portfolio of field instruments. Not only pressure, but we have temperature, level, flow meters, as well as a number of control systems. So we do SCADA, we do large, like our Centum, a large plant integrations. We also do safety systems. So it's not just instruments. And I know most of us on this call are here in the Gulf Coast area or somewhere here in the southern territory of the U.S. So we focus a lot right on chemical and oil and gas. But I mean, you can find Yokogawa anywhere where there's automation. So I know some people on this call are on the pulp and paper, or you might be pharmaceuticals or food and beverage, a number of different industries. So we're not just focused on chemical and oil, but pretty much everyone that uses automation. Now, as you can tell by the name, we are a Japanese company, but not everything comes out of Japan. So it's one thing I always like to tell customers and our reps is, hey, make sure that our customers know that we actually have our headquarters, as you can see here, is in Houston, which is pretty much the hub for North America. And then in Atlanta, you'll see right there, that's where all of our manufacturing is. So a majority of our products come out of Atlanta. There's just a few that come from Japan or Germany. So that's one thing to keep in mind. When you're ordering something and worried about lead times, we've got a factory right here. So you won't have to run into any kind of issues there. All right, so today's topic, pressure sensors. So I kind of want to talk a little bit about the different pressure sensors that are on the market. We all know, the difference between maybe absolute and gauge pressure or differential pressure. I don't want to, that's kind of elementary, so we want to talk about that. But I want to talk about kind of the working principles behind the different sensor technologies that are currently on the market. And then we'll kind of narrow our focus to just Yokogawa. So here's a slide I like to show. It kind of shows the evolution of kind of the whole pressure market. You know, in the late 60s, early 70s, when they were actually everyone was trying to create the very first pressure transmitter. Of course, you guys know it as, you know, a pneumatic or some type of force balance transmitter. Just a little history lesson. You know, it was actually a joint venture between Yokogawa Electric and Rosemount Aerospace, and they created this first force balance transmitter. And from that point, they kind of divided up the market, and Yokogawa Electric took over the Asian market, and Rosemount Aerospace took over the Western Hemisphere. So that's kind of how everything started. As you can see, things change. You know, free trade. Everyone's selling everything everywhere. As far as where Yokogawa is taking that, you can see there at the top. We started out pneumatic just like everyone else. Then we went through a stage in the 80s where, you know, we changed from a pneumatic to an analog signal, which was great for everyone. And same thing with our competitors. Everyone was switched over to analog. Then kind of phenomenon happened actually in 1991, where Yokogawa made a actual digital sensor, pressure sensing technology. And as you can see, no one else on the market has that. Everyone is still using analog signal. Yokogawa is the only manufacturer in the world to date that has a digital sensor. And we'll go into that later in the presentation. And I guess the reason why, I guess it's been what, almost 30 years now, no one's been able to recreate what Yokogawa has. One of the reasons is Yokogawa still hasn't patented that sensor in fear that, you know, people would try to copy or imitate it. So it's still something that's I guess the Japanese hold close to the heart. And they still make it in just one location there in Japan. I like to think of it as some, you know, deep basement where they have this going on, but and it's very limited access. Now, as far as the different sensors, right, we talked about the force balance, we talked about the analog, now we have the digital. If you see on the right, that silicon resonance sensor, that is actually Yokogawa's design. And we'll talk about that later, but I want to focus right now on the two on the left. This is what you're going to see. If you're not using a Yokogawa transmitter, you're going to run into these two, a piezoresistive or capacitance cell. And I kind of just want to talk about, all of these are great, by the way. They've been field proven. You know, manufacturers that use these, they have great advantages, but also they have some disadvantages, which is the reason why Yokogawa moved on. The piezoresistive, as you can see there, it's on a wheatstone bridge. It's got a diaphragm and 4 resistors. 3 of those are fixed. Basically, what happens is when pressure is applied to that wheatstone bridge, and the variable resistance value changes, the current through those bridges, and basically that does some calculation, and it tells you the pressure. The resistors change value when temperature changes, though. That's the one downside of using a piezoresistive is it has high susceptibility to any type of temperature changes. Now, the one that most people are familiar with is a capacitance cell. Great transmitter, great technology. The one, I guess, disadvantage of using capacitance cell is it experiences hysteresis, and we'll talk about that word a lot. So hysteresis means like a permanent deformation or a permanent error that you cannot correct. And the reason why that happens with a capacitance cell is that center diaphragm is made of metal. And I always like to, when I'm in front of customers or in front of reps, I like to hold one of my business cards up. And if you can kind of envision with me as I'm talking through it, if you got a business card and you kind of bend it back and forth and you stop, the shape of that business card, right, is still going to be pretty flat. But if you say you do that 100 times, or whoever just joined, try to mute yourself.
Single piece of cooling water piping out, and it's very congested.
I'm not sure. We got some feedback here. All right, thank you. Okay, so if you back to the business card. So yeah, if you flex that business card over and over, it's going to cause some type of, you know, I guess, deformation. And you can always go back, and that's what's kind of happening in that transmitter. You can go back, re-zero, recalibrate, and it goes back to zero. Great. Let's say you do that 1,000 times, right? No matter how it's going to cause some deformation, permanent deformation. No matter how many times you press on it, maybe on a countertop or put it between a book, that business card is not going to be perfect like it was before you started bending it, flexing it back and forth. And that's that hysteresis we're talking about. You can try to re-zero the transmitter, and it might show up on the display, hey, we got 0 PSI, okay, great. But actually, it's going to be off by a certain percentage the entire time. So just to kind of give you an idea of how much deformation can cause error, 1 micrometer of displacement can cause an error of 1%. And if you're not familiar with what a micrometer is, there's 25,000 micrometers in 1 inch. So just a very small amount of deformation on those diaphragms can cause a significant amount of error. So here's a closer look of Yokogawa's silicone resonance sensor. The one thing I want you to focus on here are those 2 little H bridges on top. And those are located in a certain position, and we'll talk about exactly how. But if you see, it's kind of blowing up, those 2 little H bridges. If you think of them as tuning forks, and those are resonating at a certain frequency. Actually, the frequency is 90 kilohertz. When that pressure is applied to that silicone substrate, the way those little H bridges or tuning forks are positioned, it causes one of them to go in compression and one to go into tension. And when that happens on a differential pressure transmitter, we're able to measure that difference and get a DP measurement. As you see that there, frequency 1 minus frequency 2 is proportional to DP. Now with the same transmitter, we can also get static pressure. So we got multi-sensing now. So if you buy the Yokogawa differential pressure transmitter, you're also getting you can also measure static pressure as well. So saving customers money. You're not having to buy 2 separate transmitters. You can just buy this one and get 2 values out of it. And that's proportional. F1 plus F2 is proportional to the static pressure. Very neat to know. Another cool thing is that sensor itself has a natural thermocouple between the materials in that sensor construction, which actually allows that sensor to measure temperature as well. Temperature, within the transmitter itself. So not temperature of the process, but temperature of within the transmitter, which is great for customers because if it's experiencing some high heat or something, it can send an alarm, through your control system, say, hey, this transmitter is sensing some high heat. Maybe something ambient around it is causing, it to fail or something like that. But just knowing that it has multi-sensing is great for our end users. Now, how does a transmitter actually, how does it actually sense it? Right, we talked about the piezoresistor and that bridges, talked about capacitance, talked about silicone, but what happens, okay, great, it measures it, but how does it actually, on the other end come out with a 4 to 20 signal or, whatever type of digital signal you have? Well, if you look at the bottom screen there, this is capacitance cell, for example. It's going to experience some type of pressure change. It's going to take that analog signal and bring it into a analog to digital converter within the transmitter. Once it has that digital signal, it sends that into the CPU and makes those calibrations, and then back to a digital to analog conversion and spits that out at a 4 to 20 milliamps. The advantages of having this digital sensor is that that initial signal is already in that frequency output. So it's already digital, it goes straight to the CPU, doesn't have to do any type of conversions. And then after the CPU, it converts back to analog. Now, why are we talking about this? Why is this important? Well, for one, it eliminates one step within all the computing of the transmitter. Eliminates one part where it could fail. But also, because we've eliminated that, we can get a faster response time. So on critical applications, or let's say safety systems, where all your response times are very critical, this is going to help you out a lot. And I believe we have one of the fastest response times. I think it's 90 milliseconds, so less than 1/10 of a second, you can get your readings. All right, if you've seen some of these slides, you'll see it says DP HARP. That's what we call that sensor. The HARP stands for high accuracy resonant pressure, in case you were curious. But I like to show this slide. This kind of shows the location of that sensor right above the diaphragm where it's located. So it's always nice to let customers know that, hey, this sensor, it's not behind the diaphragms, right? It's not going to experience, process or temperature changes as far as being affected. It's pretty much isolated in that neck. And here's a better example of a kind of a cross-sectional area. Some other neat features of Yokogawa transmitters. These are standard, by the way. So everything is dual compartment. All of our instruments are. So if you're out there, and the weather's not very nice and you're out there trying to wire this thing up or change something in the back of the housing, you don't have to worry about compromising the pressure sensing part or the electronics of the meter. That's one nice feature. Also, we have all of our wetted materials are Hastelloy C. That is a standard for us. It's not something you have to pay extra for. And then we also have something within the design called an overpressure diaphragm, and we'll talk about that here in a second. There's a lot of neat features, very robust design. There's still a lot of these in the field that have been working for 30 years and never had to been touched. It's pretty remarkable. So as far as performance, now before I show any type of low accuracies and things like that, it's important to understand what's really important here, because a lot of our manufacturers, they kind of battle each other, Rosemount or Hauser or Siemens or Honeywell or Yokogawa. They all try to have the best accuracy, right? That's on their spec. It's kind of a spec off between everyone. But what's really important, right, is the reliability and repeatability of the transmitter. If I say I got a very small accuracy that the customer can achieve, but I'm testing this under lab conditions, what good does that do if I'm out in West Texas or if I'm out in East Texas or somewhere where there's high temperature changes? It does me no good. So one thing that Yokogawa does is when we put a value out there, like in our documentation, where we state, hey, we've got this much, our accuracy is this good, those are actually field proven numbers. And, we only publish what the worst you could experience. So if we're saying, hey, our transmitter can do 0.05% accuracy, that's the worst you'll ever see. In fact, it's probably a lot better than that, but that's just kind of the mentality and the culture of our company. We always, notify our customers what the worst possible case rather than what the best under perfect conditions are. But that being said, we're the only ones that can guarantee this. It's pretty amazing. That's because we do have that digital sensor. We have two different lines. If you see the very top, we have an EJA and an EJX, two different series or two different tiers for our pressure portfolio. We guarantee our customers that measurement will not drift. That upper range limit will not drift for 10 years. 10 years. And then on the EJX, 15 years. Why can we promise that to our customers? That's because we don't have that hysteresis. We don't have those issues that maybe a capacitance cell transmitter has or a piezo-resistive transmitter has. And these are guaranteed under all working conditions. So something to think about when you're thinking long term. You're going to get a lot of years out of these transmitters. It's great for the customer, not great for the sales guy. Now, as far as overpressure, I mentioned this a while ago. A lot of overpressure events can happen, right, in the field. The guy's on his second shift, he's tired, presses the wrong button, operator. You got a new guy, right, with a green hard hat. He pipes something up the wrong way or opens the wrong valve. Who knows, right? We can talk about 1,000 different things, but overpressure events happen. You got a transmitter that is rated 0 to 500 psi, let's say. And all of a sudden there's a huge pressure spike. Something happens and boom, you got 5,000 pounds of pressure on this one transmitter. It's pretty much toast, right? You're not getting that back to any type of zero. You have to go out and buy a new one. Not with Yokogawa. It has a special pressure, overpressure diaphragm within, and you're not going to experience any type of damage to that diaphragm. So here's kind of show you how, here's a picture to show you how, but basically on the left, it's just normal operations. You can see that diaphragm there's an isolation diaphragm, and there's also an overpressure diaphragm that we have within our design, the one on the inside. On a normal pressure event, oops, getting some feedback. That picture on the left is normal activity. You'll see those fill fluid lines that go up to the silicone sensor. You know, the sensor experiences that pressure from the fill fluid, and of course, gives you a pressure reading. The picture on the right shows you what's happened if that pressure spike actually happens. What is it going to damage? The transmitter is going to damage that silicone resonance sensor, because once that's damaged, right, you're done. In fact, the answer is no. So when that overpressure happens, it actually, that overpressure diaphragm kind of deadheads those fill fluid lines. It prevents that pressure from ever reaching that sensor, and it transfers that energy out through the other diaphragm, to the other side. So once that transmitter is out of overpressure event, it can go back to normal operations. It's not going to damage the meter. And we've done many tests. You know, I've had people, oh, that's no way, you know, that's possible. And we've done, I said, okay, well, bring me a transmitter that you're currently using, and we'll test it. And we'll, you know, let's put an overpressure event on it and see what happens. And we'll do one with Yokogawa. Sure enough, you know, the incumbent transmitter, you know, failed after it got out of that overpressure, and Yokogawa's kept working right, you know, after that event. So it's something great to think about, just some extra kind of preventative maintenance, if you would say, or just, you know, asset management for our end users to think about.
Hey, Matt.
As far as, yeah.
Matt, and real quick, I don't know if you're going to touch on this, but I've actually seen this firsthand and tested it with a competitor as far as freezing on wet legs, and because obviously that can happen too. And if you're going to cover that, I apologize, but the same principle, correct, works with freezing on steam lines and things of that nature, correct?
Correct, yeah. So that freezing can cause some type of deformation on those diaphragms. Yeah, and that's something that, you know, we hear a lot of in the field, and yeah, you won't have that issue with these transmitters.
We actually had one when I came to work here, that a previous salesman in the Panhandle area up around Amarillo had a power plant where every transmitter, while they were building it, had froze. The plant was shut down. It was a peaking plant, and it had shut down, and every plant had froze. And he went out because they thought, you know, these transmitters are going to be destroyed. And literally it was 40 something transmitters he told me about, and not a single one did not, you know, every one of them went back to zero and performed well for years.
Hey, Jason.
Yeah.
If you get a chance at the end, we have enough time, you might share your screen and pull up the video that you did of the freezing the two transmitters side by side and watching them perform. I think that's about a 5 to 7 minute video that anybody that wanted to hang on the line might be interested in.
Yeah. Thanks, Craig.
That's a good point.
Go ahead, Matt.
Yeah, thanks for sharing that story. People don't know I'm just not lying to them. As far as features, we'll go over those briefly. Of course, you can communicate with our transmitters through, you know, whether it's a 475 handheld or it's Yokogawa's handheld, the 5150, or maybe you're using a laptop. You can program the transmitter, you know, either way you like. I know that the 475 has been discontinued, and they're kind of requiring customers now to use tablets. But Yokogawa still offers our handheld communicator. So if you're in need of a new one, you know, contact your local account manager and you can get one. Just one side note on that, I'll just kind of put a little plug for the handheld communicators. One benefit of using Yokogawa's handheld is that it accepts all raw data, all raw files. So say you got a new Emerson transmitter or a new Vega, or, you know, whatever manufacturer, Yokogawa transmitter, you can download those DDs or DTMs and program the meter right away. But with your 475, Rosemount's kind of done something kind of, you know, great for them as far as, you know, marketing. But when a manufacturer comes out with a new product, you might have to wait a couple months for Rosemount to convert those files, kind of like translate them into the language or protocols that communicator actually reads it in. So one thing to think about when you're using Yokogawa, handheld, you can get everything right away. Now, let's say you go out to the field and you forgot your handheld communicator, you don't have a laptop, or you just need to make some changes right there at the transmitter. You want to do it through the display, no problem. You can configure everything right there. On the side of the transmitter, there's actually a little zero adjustment screw. If you get on LinkedIn a lot, I know Jason Ballard has a great video where he actually shows his daughter, I think she's 13-year-old daughter, that programs the transmitter by herself, and shows how easy it is. So I know if she can do it, pretty much all of our customers should be able to do it with ease. And you can do a lot.
And I can also offer contractor rates there. No, I'm just kidding.
So through that display and that adjustment screw, you can pretty much change all the important stuff, right? Your tag numbers, you want to change your units, your lower, upper range, any type of dampening, things like that. It's very, very easy to use, very user-friendly. All pressure transmitters can pretty much communicate all these protocols, but we offer all the same. Of course, HART, field bus, Profibus, HART protocol for lower power. You'll see Brain. If you're not familiar with Brain, that is a Yokogawa proprietary language. And then the one thing that's not on here that I should have added was Modbus. We do have Modbus as well on our multivariable transmitters. As far as wetted materials, like I mentioned before, all of our wetted materials are Hessel C, where normally that would be an upcharge. That's a standard for us. But we have if you have maybe a really tough application or corrosive or just harsh environment, we offer other exotic metals as well. As far as safety approvals, you don't have to worry about that. We have pretty much all the global safety approvals you can think of. As far as mounting, pretty much same for every manufacturer. You usually got a U-bolt or some type of L bracket. I think Jason actually makes some of those in his garage at one time for customers in the buying. Another great thing about Yokogawa products in general is the safety standards that we put within each product. And a lot of our competitors, they'll charge for maybe a SEAL 2 rating. You're not familiar with SEAL. That's a certain safety spec you have to be at for safety systems. All of our transmitters are SEAL 2 rated out of the box. That's just a standard for us. And if you need a SEAL 3, you can just put 2 of these in a series or in a loop. So just another benefit to our customers. Oh, I want to go back. If you see that little red, so our transmitters are green, right? But you can get different colors on your transmitters. I've been to plants where maybe they have a safety system with all their transmitters on that, and they want to let people know in the field, like, hey, this system, if you see a transmitter with a red cover or something like that, that's part of our safety system. Don't mess with it. Just keep them where we can also offer that different colors if you guys like them. Now, as far as the different transmitters, I put 3 up here because there's still EJAs out in the field. We don't. That was our first transmitter we ever came out with. They're still working fine, but nowadays you'll only see the 2 right columns, which are the EJA, EJX. Very high accuracies. We talked about that stability, right? 10 to 15 years. Very fast response times. So just let you know, kind of a good, better, best tier right there. 0.04% accurate. I did a presentation before, and I had a customer say, well, I don't really care about 0.04. I mean, that sounds kind of crazy. I just want to make sure that it's, at least better than 1%, right? I said, I hear you. But, it's nice to know that you're getting a product with a lot of quality behind it. And that's the kind of message we want to show. Not only are your measurements, highly accurate, but they're of high quality, a lot of repeatability there. As far as all of our offerings, we talked about DP a lot today, but we have a number of gauge pressure, draft pressure, absolute pressure transmitters. You can do direct mounts. You can do diaphragm seals, pretty much everything you can think of as far as a pressure application. Well, one thing that's not on here is we also have wireless pressure. So if you're thinking about, integrating wireless into your plant or facility, we can help you out with that as well. We're at 33 minutes now. So, and this is just, kind of shows you a picture of different applications, right? You can use DP, differential pressure transmitters, for a lot of different things. And in fact, there was a study done for typical applications using differential pressure, and actually half of them are actually used for flow more than anything, on an orifice plate or something like that. But you can also use them, of course, obviously pressure, but also level, within a tank or something, using those seals. So that's all I had as far as the differential pressure transmitters. I think we're at about 33 minutes. Just to kind of recap before everyone leaves or asks questions, what did we talk about today, really? What did we learn about Yokogawa? We learned that, right, we are a digital sensor, the only one on the market, which gives you better performance, accuracy, and stability. We get a lot of reliability from these, right? We have the overpressure protection. Right, safety is a big deal, Seal 2 rating. Another neat thing I forgot to add was that because it's a digital sensor, right, that's an active sensor. So that transmitter is constantly asking itself, what's the pressure? What's the pressure? What's the pressure? What's the pressure? Where a capacitance cell or piezoresistive is a passive sensor. So it's not going to be asking itself that all the time. It's only going to do a calculation once it experiences a change in pressure. So that's another thing to think about. Also, the ease of maintenance with our Yokogawa transmitters, right? There's no recalibration, no hysteresis. So say you got you buy a Yokogawa transmitter and it's programmed or spanned for 0 to 1,000 psi, and something in that application changes, and now you want 0 to 100 psi. You can literally just go up to the transmitter through the display or through a communicator, change that range, and you're not required. You don't have to recalibrate it, which is something you would have to do normally. Just something to think about. And we didn't go into remote seals today. We can do that another time, but I put on our noise canceling. I just want to touch on this one thing. On our remote seals, we have one thing that Yokogawa does that's really nice is we do something called dynamic and environmental compensation. I think the biggest challenge our customers face with remote seals is a temperature effect, whether that's ambient or process. And what Yokogawa does is we take those seals attached to the transmitter, we put them in a kind of a temperature room or an oven, and we test it. We apply a pressure or apply a level at different temperature ranges or different temperature sets, and those are programmed into the transmitter so that when it experiences a temperature change in the field, it already knows how to compensate for that, and it gives you a stable measurement. All right, so that's all I have today, guys. I appreciate you guys joining. Jason, do you have any questions?
Yeah, the only one so far I've got is I've got a couple here. One of them is what do you recommend is the best software for laptop programming? And as far as a lot of the guys use, because a lot of them are a customer. What is I know FieldMate, which is the Yokogawa software. Can they use Packware? I was asked on this one.
Yeah, you can use Packware, but FieldMate's a great software to use. It's free. You can go to yokogawa.com or just Google FieldMate and Yokogawa, and it'll show up a link. You can download it on your computer. Yeah, it's free. I mean, you can use it as many times as you want on as many transmitters as you want, and it's a pretty good setup.
And the next is the minimum. They want to go over minimum turn down. So the turn down on these transmitters is 100 to 1. That's your maximum minimum. I mean, it can be whatever. I believe on our multivariable transmitters, I think you can go 200 to 1. But on our DP, on our standard models, you can go 100 to 1 turn down.
Hey, okay. Matthew, this is Charles.
Hey, Charles.
How you doing, man?
Hey.
So, yeah, it depends on the particular model. They're not all uniformly have the same turn down. Some of the capsules have a larger turn down than the other, like with our EJ E series, right? It's 100 to 1, 400 to 4 inch is a typical M capsule. If you go to the EJX, it actually gets 200 to 1. You can go 400 inches down to 2 inches. So, but they all have a very large turn down because of the high resolution of the HARP sensor. And the fact that we're frequency based, we're more linear just in the nature. And we don't have to do all the characterization to our sensors like the other types of sensors require. So that allows us to do the larger turn downs and also avoid the calibration when you rearrange them. Because when you pick that new point for your span and zero, you have to adjust those to keep that fine accuracy. But with ours, you're able to cover the whole window of that capsule and meet the published specifications in the GS just by assigning a new zero and span setting. So that's the advantage.
And Charles, also, and isn't the D capsule, because I have a lot of upstream oil and gas people, a couple of them are on here, the D capsule on the EJA, your 7200, I believe it's just 10 to 1.
And like I said, it's specific the different.
But that's also because if you're going that low, we would go with the C capsule. You know, it would cover all those ranges. We can cover any range you have. Is basically where we're going with that, and that we can help with any application you got is the main answer with that. But typically, a lot of them are 100 to 1 and 200 to 1. Just like Charles, just to kind of reiterate what he says, it's according to the actual transmitter, and we'll help you with that spec. Yeah,
and one more comment. It's not all weighted as Hastelloy. It's our diaphragm is Hastelloy. That's our standard material. And the reason we did that when we released the series was, you probably noticed over the years the transmitters have gotten smaller, and as a result, the capsules get smaller, so the diaphragms get smaller. So to keep a spring rate for sensitivity for passing these smaller pressures, the diaphragms become thinner. So Yokogawa upgraded the diaphragm material from stainless to Hastelloy, right? Because Hastelloy has better resistance properties over stainless in most applications. So that was a step to extend the life of these transmitters so they will be as robust and as long lasting as the 25-pound ones you bought back in the 60s and 70s, right? So.
Hey, Matthew and Charles. This is Mike Morrow here. I had a question. Or actually, could you get, not really a question, but could you guys go over and talk a little bit about the dynamically compensated remote seals where we utilize that extra capillary for environmental effects?
Yeah, Charles, you want to take that one?
Okay. So the dynamic compensation is the sensor itself, right? So you see the first slide there. That's in our standard product. If you're using impulse lines, if you're using our remote seals, you have the advantage of the dynamic compensation and the fact that our transmitter sensor is live, the HARP sensor is live. We're measuring the DP, we're measuring the static influences, and we're able to monitor the temperature at the transmitter, right, where the sensor is itself. So we can make adjustments for that dynamically on the fly as we're in the field making these measurements. A lot of times, if you're making a DP measurement and then you have a large static load that comes in, right, you pressure the tank or something, it's going to shift your DP measurement. So we have an offset for that because we are monitoring static with the DP. So we compensate for that, right? Dynamic compensation. Then when we build our standard sensors in that second slide at the top, we do environmental compensation. So we put them in these environmental chambers, these ovens. We cycle the temperature. So we build those characteristics in so that when our sensor on the transmitter picks up these pressure temperature changes, it's able to compensate for the effect of the fill fluid from the side, both legs. And then in third, which is in the middle at the top, we have some parameters for doing active capillary density compensation. So this is something that's available to the customers once you install it if you want to really fine tune and remove as much influence as you can from your measurement, you can go in and put the installation X and Y's of your high and low side and the transmitter in relation to that, and then we can calculate the density based on the height of that fill fluid as it changes over that temperature spectrum that the transmitter is reading, right? So to offset for the changes in that density. And the dual compensating or single compensating pickup where it says new on the end. So we can do a direct mount with a compensating leg. So think of it like a 3-wire RTD. So you've got a direct mount on your high side, you've got a low side that runs to the top of the tank, and then you have a compensating leg that runs parallel to it, right, in the same wrap. And what that does is, as that leg sees expansion and contraction due to ambient temperature, the compensating leg reacts identical, right? And then they come back to the transmitter. The one leg goes to the low side because it's a low measurement. The other one goes to the high side. So now here you go. Here's even better. And you'll notice at the top, the one that goes back to the high side, the green one, is actually stops just short of the diaphragm because you don't want to compensate for that pressure. That's what you're trying to measure. We're just measuring for the volume and the length and the temperature effect to remove the ambient temperature from causing that swing from day to night, spring to summer, winter, whatever it may be, and just keep a straight and reliable measurement. We actually did a demo of this at our user conference, last user conference we had, where we had it in the room, and it was about 70 degrees, and then we had heat wrap around the capillary length, and we were cycling it up to about 180 degrees and back down. And you could see the output. I mean, you could see the temperature measurement on a recorder that we had, and we monitored the output, and you saw that it was completely stable the whole time as we were cycling up and down. So it's pretty incredible. And we've got a few customers that have installed them and are pretty impressed with them. And then to take it a step further, we can do dual compensating so that we have a compensating leg on both sides, the high and the low. And these are really good if you have a very low DP, say 20 inches or less, where that a small amount of temperature influence could really create a large error, right? Because if you get, half an inch and you got a 20-inch span, you've got a significant error there. So what this does is allow us to compensate for ambient, again, being on the low side that goes up, and the high side goes all the way to the process. So we can compensate for ambient and process temperatures in that case. So
yeah, that's the one I wanted you to go over, the capillary compensation. I wanted everybody to hear that. That's a pretty unique deal, and that companies like Dow have done a lot of testing on that, where they wanted to move to different technologies because of those ambient temperature effects, and this right here takes care of it. So I just wanted everybody to hear that.
Yeah, and it's newly released to us. Maybe a year and a half ago, we started promoting it in North America, but they've been utilizing this in the Asian market for over 10 years. So there's a lot of satisfied customers out there with it already. So, and then we have our digital remote sensors as well, so which eliminate the fill fluid, and you get two electronic transmitters that talk proprietarily back and forth to each other. As far as the customer is concerned, the user, you guys, it is heart-based, right? So you communicate to it just like it's a single transmitter at the master, which is the one with the display, right? And then the other one is the responding transmitter, and it just picks up the static pressure, and they do the calculation internally, and then you get your output based on, what the volume is without the need for fill fluid. So these are good for large vessels and things like that, where sometimes you can't even physically get a capillary length that long, but it also helps remove, again, temperature influences, whether it's hot or a cold environment with long capillary lengths. And you can avoid, the issue of having to heat trace as well.
Thanks, guys.
Thanks, Mike, for the question. Does anyone else have any more questions that we can help with? Well, with that, Matthew or Charles, do y'all have any more you want to add before I close this out?
I think that's it, Jason. We appreciate it. I guess I can add this one slide. You know, if you took contact to your local Techstar sales guy, you know, if you have a differential pressure, a differential with seals that you need, they can give you this form right here, an electronic form you can just fill out. Obviously, there's a lot of different types that we talked about the single, the dual. This just helps us, you know, get a better idea of your application. We can give you guys, you know, the right solution. But other than that, yeah, we're done, man.
So yeah. I want to just reiterate something that was said earlier. That I actually worked for a competitor before coming over to Techstar, and I will say that something I learned coming over here was that, you know, the majority, I mean, that you will ever see in our area as far as transmitters sold here in the U.S. are going to be shipped from our Sugar Land, our Houston and Atlanta areas. And if they're not coming from Japan, and here at Techstar, you know, we keep a wide range of those products actually on the shelf as far as pressure and DP, in case you guys have some plant shutdown situations where you needed it yesterday. We're here to help. And as far as a group to work with here at Techstar, you won't find a more knowledgeable and helpful group. Just call our office, 281-542-0205, or if you want, email or call me, and I'll help get you with your local rep. And look, if you want to, I know there was some stuff about my videos and stuff. If you get on LinkedIn, you can find it. Just find me on LinkedIn, Jason Ballard, and you can see it there, or give me an email, jballard@techstar.com, and I'll be glad to help you guys out. So I hope y'all enjoyed it, and even better yet, I hope y'all that are buying Yokogawa learned a lot more. And if you're not, I hope you saw the reasons why you should. So thanks, guys. I really appreciate you.